the length, what we do in RG swing based off of the formula, the length on the y-axis, 2.576. So xy, so 576, so that creates our differential. The difference between the length versus width of those two is overall differential. Now the secondary, or the third factor I should say, not secondary, the third factor is the axis that comes through at 90 degrees to the y. This is the z-axis. Now the z-axis, if the difference between a symmetrical and asymmetrical ball is there is more than a 10 difference between the y-axis and the z-axis. Okay? So there's, if we look at it from this direction, we can see the narrowness here, but if we look at it here, it's the total overall thickness there. So what we get is an asymmetrical part. We create that x, y, and z. So the difference in an asymmetrical is we create a greater difference of 10 between the y and the z-axis. But what's unique about this product too is many of you have seen in the last couple of years there's a product on the market called a determinator. Now I don't know if anybody in the room has a determinator. Nobody has a determinator. Actually, it's a very good product to have. What a determinator is, it's a free spin machine. So what it is when you place the ball onto the rollers and turn it on, what it does is it free spins it, and what it does is it gets its axes to line up so that basically what we get is that the x-axis is tumbling end over end in relation to the y and the z-axis. So it always locates the y-axis or the strong preferred spin axis. It's a nice machine to have that when you're drilling balls, you can always take a ball before drilling, put it up on the machine, check to make sure that this locator is in the right spot. And then after drilling, you can always take it and spin it too to see if it maintains the spot. Or in a symmetrical ball that does not have a marked mass bias, we can also utilize that tool as well to see where it actually is the strong point in the ball. Okay?
Or if you do a lot of plug and redrills, for example.
Exactly.
Sometimes that spot will change depending on how many times you adjust the densities within that by plugging and redrilling the bowling ball.
A great point, Steve. Another thing is too is if this product gets transferred onto another player and you plug it up, we're always going to make sure that it still stays in the same spot. Many times it'll be pretty close, but sometimes if you do drill some large holes and some mass, you are going to move the shape slightly and shift that mass bias a little bit. So what we came up with this cell course. So we've created what I was looking for. We've created the asymmetrical within a basic symmetrical overall shape. But another key factor is, in that determinator I got off the subject here, is in the determinator, they use it to dictate how strong a core is. So in the determinator, they use it what they call 60-degree spin time. It's where you're placing the actual pin and the mass bias roughly about 4 inches from the player's axis. And you start that spot, that 4 inches, on the marked indicator position. You start the machine up, and the time it takes to spin up to its preferred spin axis is they mark as the strength of the core. Now, this ball has a 5-second spin time, which is very fast, very strong. But what's unique about it is it only has an 18 split between that y and that z axis, which Mr. Pennell would probably tell you this ball should not spin that fast because it's not that strong between the y and z axis. But also, too, as part of it is shape. Shape dictates how fast it'll get there, too. Not just what's the actual split, but the actual shape itself will enhance that. RG values will enhance it, too. The lower RG values will spin faster, too. So this is a very strong part, deceptively strong, even stronger than what the numbers say. So we'll go to the next slide. So kind of give you a little bit of overview of this core itself. So when we talk here, you got pin, CG, it's a Pro CG. Pin, CG, mass bias. So this is basically what we see as the front view. You can see the dynamics of the shape, symmetrical, and we have that protrusion in the inside to help us create the asymmetry. But if we look at the side view, and this is where I really want you to focus in on the side view, this side view of this core, here's where my whole philosophy came from. Was that what I was trying to do is I was trying to maintain a differential of a bowling ball as it's traveling down the lane so that it's always continuous motion. It never loses it. Because what happens with a lot of parts as we shift this part, so when I swing it on RG swing, it gives me an axis based off of that spot right there versus these two. if I tilt this ball slightly, say an inch away from the pin, and I swing the RG axis again, see how the weight block maintains its length? It maintains its differential. And as I tilt it farther, it still maintains it. That's the idea of that as you tilt it. If I can do that too, will you do me a favor? Gravity shift, sitting on the rack out there, has the 3 pieces of tape. It's my ball. Will you grab it for me? Thank you. I want to show you a little something here. If we'll take a little. But what we're trying to do is we're trying to maintain this differential as we tilt it. Because when we first set this ball up and we put the pin, say, 4 inches from our axis, and it's 4 inches, and this ball has 56 differential, but when we place that ball that's 4 inches from our axis right off our hand, it's a spot about, say, right here, right? And I'll give you an example with this one. Even though this is it's a gravity shift, I'll show you something here. Same principle. What we see is pin distance from the PAP is 5 inches on this ball. And what this is we see the axis migration. And as this ball is traveling down the lane, this is the initial axis. As it's traveling down the lane, here's an intermediate axis, an intermediate preferred spin axis. And then the final preferred spin axis is right here as it travels into the pins. Now I want you to notice something. On the initial ball, this is 5 inches from your axis. Halfway down the lane, it's 3 inches from your axis. So it's switched to a different plane in the weight block, right? And then at the pin deck, it's roughly about 3 inches as well, 3.5 to 3. You see that? So what's happening is this core has different strength as it's traveling down the lane. Off our hand, if this is the initial axis off our hand, bear with me. If this is the initial axis off our hand, at this point right here, I want to show you, Steve, if you'll hold that right there. So here it is off my hand, and if we did an RG swing, and I've done it with this ball, and done it with the cell, and I've done it with all of them. If we do an RG swing to see what's the differential value off a player's hand, this one has about 40 differential off the hand. But as it gets to here, it actually loses differential traveling down the lane. Because at one point, at about 2 inches, see the length versus width? They start to go away from each other.